discover the power of Jovan Muscoil for men.
Just created a nuclear bomb. Does it feel nice?
No.
Why are you sniffing his hat? What does it smell like, Franco?
Smells like heaven.
Men and women together than any other fragrance in history. Muscoil, another great gift idea from Jovan.
How do we extract smells from things that just naturally appear in our world? It seems like an impossible task until you get an education and discover what esters are. Esters are essential to the cosmetic, food, and chemical industries as they serve as a class of stable organic compounds that produce a wide range of odors, some of which resemble that of fruits, flowers such as pineapples and oranges, and even the earth apparently. Nonetheless, there are two main reasons as to why we chose to research on esters. First, we wanted to find out how some artificial flavors and smells are manufactured with the multitude of products we have access to. And secondly, we were just told that this would be the most dangerous lab, but that's besides. We established that through the synthesization of mainly acids with alcohols, we would end up with products that would have a distinctly pleasant smell, or one that could pretty much kill anything that is so unfortunate to come across it. Except that is nearly exactly what happened, but with our entire class. For example, one of the procedures suggested that by mixing acetic acid with butyric alcohol, it would end up smelling like either pears or apples. However, if anything, it smelled like nail polish, and a really plasticky nail polish at that.
It smells like nail polish, that's what it smells like. Like really strong nail polish. You can smell it from all the way over here.
And it was at that moment when we concluded that either the chemicals have since then deteriorated heavily upon sitting in a box for years, or the people who have made the booklet needed to smell grass. With the usage of esters, we are referring to the organic chemistry unit of the course. More specifically, we are exploring the nature and classification of organic compounds and their uses in modern materials, with their job also being able to find which class of organic compounds do the chemicals we use belong to, including cyclics, aromatics, alcohols, aldehydes, ketones, ethers, esters, organic acids, and halocarbons. This of course successfully done so with the numerous tools at our disposal given by our teacher.
We had to use a wide variety of equipment to successfully synthesize our compounds. More specifically, a hot plate in which the heat would help not only activate the acids, but would help catalyze the synthesization of our test chemical. We also used 8 300 milliliter beakers in total throughout our trials, an ungodly number of pipettes, a stirring stick, a clamp to hold our test tubes while it's being heated up, a test tube tong, a thermometer to record our temperatures, and a rubber heat safety glove. It's also worthy to note that our package contained many different compounds that could have been also used, but we only had enough time for 2 different trial periods, one of which included the usage of acetic acid, and the other including butyric acid. Distilled water was also used to dilute the newly created esters to reduce the chance of interference of other substances in the samples. Now, some of these chemicals we had our hands on are very dangerous if we're physically exposed to them, as well as the fact that we are working with boiling temperatures.
Since we were handling chemicals that could literally melt every cell off your body, we had to take numerous safety precautions. In fact, we were so safe that we only had to remind ourselves once not to touch the hot plate.
Yeah.
Okay, and don't touch that hot plate.
Idiot.
We wore aprons, plastic gloves that were a pain in the to put on, goggles despite some of us wearing glasses instead, and as we mentioned already, the rubber heat safe glove to remove the hot beaker. However, our safety concerns were not just limited to the physical properties in front of us. We also had to be mindful of our surroundings as there were others also working around us. Lastly, we needed to ensure that our environment is clean and tidy so that we are organized and so that the next class would not have to spend half their time throwing away our stuff. So, what's next?
The instructions we were given by the booklet were simple enough, but we did not, however, have enough time to form ethyl butyrate due to time restraints. Despite this, let's begin. We first prepared all our materials, which were organized in a way that could be easily accessible, and then we started with our first step, which is that we needed to create a control substance to compare the smell to our newly created products. It consisted of 2 milliliters of acetic acid, 1 milliliter of sulfuric acid, and 50 milliliters of distilled water. What we noted is that it gave off a burnt plastic smell that is fortunately not even as repulsive as the others. We then had to prepare a 400 milliliter beaker where it would then be filled with 350 milliliters of distilled water. This beaker would then be placed on a hot plate so that the water can reach a boiling point. The hot plate would then be immediately turned off following the appearance of the water going bubbly bubble. We would have 4 test tubes labeled 1 to 4. And since this was the acetic acid trials, we used 10 drops of acetic acid and 2 drops of sulfuric acid for each test tube. And for each of those tubes, they would have a designated alcohol, for which we will see what they will smell like. One of the test tubes would then be placed in the boiling hot beaker for approximately 5 minutes. I say approximately 5 minutes because while we did use a timer, you will see soon that there are a few moments where we didn't really check the time and we were off. Fortunately though, these errors never really affected our outcomes on a drastic scale. After the boiling process is complete, the test tube would then be poured out into a 250 milliliter beaker filled with 100 milliliters of distilled water. And the results may vary. Sometimes we would mix for a few minutes and then we would get the smell, and then other times we would mix for about 2 seconds and then we would get the smell. So now let's go over each alcohol we used and what their outcomes were. Test tube 1 included the use of ethyl alcohol to create ethyl acetate. The peak temperature was 90.3 degrees Celsius with it being heated for 5 minutes. The observation in the booklet noted that the scent produced would smell kind of fruit and sweet. However, at least according to what Reggie's notes says here, it smells more like motor oil. But I would say that a more accurate depiction is that it smelled like the Industrial Revolution in 1836. So this one was kind of a failure. Test tube 2 used butanol to create butyl acetate. The peak temperature was 92.0 degrees Celsius and was heated for 5 minutes. Its projected outcome was that it would smell like bananas, and while at first it did smell quite awful, after a while of mixing it, it did start to resemble that of bananas. So this one was pretty successful. Test tube 3 uses octanol to create octyl acetate. The peak temperature was 92.5 degrees Celsius and was heated for 4 minutes and 35 seconds. Its projected outcome was that it would smell like oranges or a general citrusy scent, and almost immediately after mixing, the description was actually fairly accurate. Although we did make 2 crucial mistakes here. First is that the pipette we used caused excessive acetic acid to leak into our mix. Secondly, our time was 30 seconds off. Test tube 4 uses methanol to create methyl acetate. The peak temperature was 93.2 degrees Celsius and was heated for 5 minutes and 30 seconds. Its projected outcome was that it would smell like glue or nail polish remover, and it smelled so much like nail polish remover that at that moment we wanted to remove our own lives. The next scents are being produced with the use of butyric acid, while also following the exact same procedures as our last trial. But first, can I say that this thing could have very well given us lung cancer just from the sheer smell it gave off upon opening it. I mean, the stench got so bad that our substitute teacher had to bring out candles that were laid across the room. And all of this done just so that there's a slight chance that it could mask it away from our noses. Anyways, here's our results. Test tube 1 used butanol to create butyl butyrate. The peak temperature was 94.0 degrees Celsius and was heated for 5 minutes. Its projected outcome was that it would smell like pineapple, and this I would personally say was the nicest smelling of them all, so this one was a major success. Test tube 2 used octanol to create octyl butyrate. The peak temperature was 93.5 degrees Celsius and it was heated up to 5 minutes. Its projected outcome was that it would smell earthy and flower-like, and we were blessed once again as it smelled like opening a fresh box of Tide Pods. Test tube 3 used methanol to create methyl butyrate. The peak temperature was 94 degrees Celsius and was heated for 5 minutes. Its projected outcome was that it would smell like apple or pineapple, but it was really off the mark with this one. We believe that there might have been some additional butyric acid that was added by accident. So yeah, that's how we found out how us. Hold up a second! Hold up! I just forgot to mention that this hot plate you see here is not actually real. You see, we cranked this hot plate to its maximum setting, and after waiting for approximately 15 minutes, our water wasn't even simmering by then. And despite it being brand new and coming with other handy appliances, it failed to serve its actual purpose. Luckily though, we were given a few occasions to steal hot plates from other groups. Now let's have Reggie explain some of the background information of this procedure and how esters are important to our society.
So what are esters? Esters are groups of chemical compounds formed by bonding an alcohol group with an acid group. Esters are also a derivative of the family of carboxylic acids. Esters are formed through the esterification reaction, an exothermic reaction that produces a byproduct of water. Often, a strong catalyst accompanied by heat is used to hasten the reaction. Sulfuric acid served as our catalyst. Let us look at the formation of butylbutyrate, one of our lab attempts, to see how an ester is formed. Butylbutyrate is formed by reacting butyric acid and N-butanol. Sulfuric acid, along with heat, is used to speed up the reaction process. A hydroxide then breaks off from the butyric acid, and a hydrogen breaks off from the butanol. The butyric acid and butanol then synthesize to create butylbutyrate, creating the sweet smell of pineapple. The traditional method for creating esters was used in the lab, which means traditional technologies were used to create the esters. One machine used in the creation of the esters in the lab was the hot plate. The hot plate sets up an efficient way of producing heat to increase the temperature of the beaker holding the water bath rapidly. The hot plate allows for quicker procedures and portability. However, recent technologies have been created to further increase efficiency. Ultrasound is emerging as a more efficient and cleaner technology for creating esters. This new method can increase the initial rate of esterification and boost the scale of mass transfer of the reactions. Furthermore, additional technologies are being created to further increase the efficiency and cleanliness of esterification. One such technology is DowXH+. DowXH+ is a cation exchange resin, meaning that it is an ion exchange resin that contains acidic groups for exchange cations. It is used as a catalyst system for many kinds of esterification reactions. Furthermore, DowXH+ is highly efficient, non-toxic, and reusable.
Esters are taken by many businesses as a prosperous opportunity to make millions. As mentioned previously, esters are used in fragrances, food flavorings, and the general chemical industry. But they are also used in essential oils, hand sanitizers, and acts as solvents to form coatings, paint, and varnishes to polish surfaces. According to an article on Yahoo Finance, the most consumed ester in 2021 was ethyl acetate. This was especially in regard to the personal care product and cosmetic industry, as ethyl acetate is not only used to add pleasant scents to fragrances and perfumes, but it also evaporates quickly on the skin so that there's no residue from usage. Esters are also commonly used in the pharmaceutical industry, more specifically in the creation of aspirin and mark oil. One of the active compounds in aspirin is salicylic acid. Salicylic acid contains both a hydroxyl and a carboxylic group, which means that it has both the capability to react with an acid or an alcohol. In the case of aspirin, it bonds with acetic acid, which is used to negate the taste and the acidity of the pill when taken. While esters are not necessarily vital for society to function, they have immensely helped in the area of
if you stink like poo-poo, you can cover yourself up.
While esters provide considerable quality of life benefits, they come at some environmental consequences. One ester, 2,2,4-trimethyl-1,3-pentane-diol diisobutyrate, was found to be an ecological hazard because of its potential to bioaccumulate. Another ester, docusate sodium, was found to be moderately ecologically hazardous because of its overall ecotoxicity. Other substances, while only having a low ecological hazard potential, still have a chance to harm the environment.
Good God, does all of our backs hurt? After numerous burdens and victories, from faulty equipment to getting short bursts of dopamine to maybe almost setting the fire alarms off, what have we learned? Well, we learned a lot more about the impact esters had on industrial manufacturing, especially since practically every product relating to our sense of smell and taste use esters. And despite really our intention was to play around with sulfuric acid, it was actually pretty interesting to see the framework of how these chemical reactions occur. Please, I don't know who'll be watching this, but be extremely careful when opening butyric acid unless you're a crime scene cleaner, in which you're good to go, but please, make sure the coast is clear before doing so. Otherwise, you may cause tears to come out of a few people. Thank you for watching.
Out of algae in oceans and other water bodies.
What do you think of what Reggie just told us, Ranko?